Okay, I think I have a little bit better angle on the paper this time, so that's good. So now we need to talk about continuity on an interval. If a function is continuous at each point in an open interval, remember we talked about what it means to be an open interval the other day, then f is continuous on that open interval a to b. If f is continuous from negative infinity to infinity, an open interval, then f is considered continuous everywhere. Okay. And then we have a couple other definitions about this. A function is continuous from the left if the limit as x approaches c from the left of f of x is equal to f of c. It's continuous from the right if the limit as x approaches c from the right of f of x is equal to f of c. Okay, so let's talk about what we might do with this problem. What can be said about the continuity of this function? And because we're specifically looking at this interval from a to b, let's talk about that. So first of all, because of this, okay, this is going to indicate that we might have some sort of discontinuity. So we might take a look then back at our couple of definitions here. A function is continuous from the left if, as x approaches c from the left, f of x is equal to f of c. So if we're talking about this particular one, we would need to look at the limits as x approaches. Now we're going to be talking about b from the right. Does that limit equal f of b? Okay. And we'll put a little question mark up here and we'll say, I'm not sure. So this would be, is it continuous from the right? So I'm approaching b from the right. The limit is some value up here, which is also the value of f of b. So we might say yes. Okay. Oh, let's see. I'm going to be running out of space soon. And then we would look to see if the limit as x approaches a from the left of f of x is equal to f of a. Okay, so now we are trying to approach a from the right. Oh, sorry, this one was from the left. Sorry, this one's from the right. Well, I jacked that all up. Yeah, sorry, we were approaching b from the right. We're approaching a from... No, we're approaching b from the left. Wow, I can't get it together tonight. We're approaching a from the right. And we know that the limit would be here, some value. Okay, this would be the limit as x approaches a from the right. I'm going to get it right this time. And this point up here would be f of a. So that limit and that value, function value, do not equal one another. Okay, so what can be said about this particular function is that this function is continuous from the left, but not the right. Okay. All right. Next we have oops, I have to move it up. Sorry. Here we go. A function f is said to be continuous on a closed interval. So remember, a closed interval, we have brackets. Okay, so we're dealing with brackets. If, again, three conditions. F is continuous on the open interval a to b. So that has its own conditions to be met. If f is continuous from the right at a, and if f is continuous from the left at b. So we're going to take a look at an example. I'm going to turn the page again. Here we go. And we're going to look at this function. We're going to determine the continuity of this function, f of x equals the square root of 9 minus x squared. Now, this is why we had to talk about domain the other day, because what we need to do is first determine the domain of this function, because that's the only interval that I need to look at. So let's recall how we can find this domain. We're dealing with a radical. We know that the radicand, the stuff under the radical, has to be non-negative, or we say greater than or equal to 0. So we will find the, my husband and son just got home. They're trying to make me laugh. Okay, so we need to find this domain. We'll set this greater than or equal to 0. So we need to find the x-intercepts. So we're looking at trying to solve this equation. This is 3 plus x times 3 minus x. So x would equal negative 3 or positive 3. So that's what we're looking at. Those are our x-intercepts. Now, if we just think about what this graph would look like, this is a parabola. This parabola opens down because we have a negative x squared value here. So it's going to open down, and it's going to cross the x-axis at these values, right? So it does something like this. We don't really care. And we wanted to know, where is this function positive? Where is it non-negative? Well, it's going to be non-negative between negative 3 and positive 3. Okay? So, domain is the closed interval from negative 3 to positive 3. Okay? So, we need to look at negative 3 to positive 3. Okay? So again, let's go back for a second. Right? A function is continuous on this interval, right? This is the only, our negative 3 to 3 is the only interval where that function is even defined. So it'll be continuous if it's continuous on A to B, the open interval. Okay? Now, keep in mind, we said that it would be continuous on A to B if the limit as x approaches c of f of x is equal to f of c. Okay, this is what we need to find out. And we kind of take this from the definition of continuity, that f of c has to be defined, this limit has to exist, and these two things must be equivalent. And so without having to look at each of them separately, we can kind of look at all three of those together. So we'll know that this then is going to be the limit as x approaches c of the square root of 9 minus x squared. We want to know again, is that equal to f of c? Okay. But this limit, we know we can rewrite as the square root of the limit as x approaches c of 9 minus x squared. And we have f of c. Then, in order to evaluate a limit, and c, just standing for some number, we would plug in c in place of x. We've actually evaluated the limit now by calling this 9 minus the square root of, the square root of 9 minus c squared. Is that the same as when I put c in place of x? And it is. Okay. All right. So now we go back for a second. Right. So we determined that f was continuous on the open interval from negative 3 to 3. Now we need to determine if f is continuous from the right at a. Okay, so we're going to need to move this down a little bit. Okay, so sorry, this was really condition number 1. Down here we'll have condition number 2. Oh yeah, we need to know that it is continuous from the right. So we'll have, is it continuous from the right at A? Then we need to know, is the limit as x approaches -3 from the right of the square root of 9 minus x squared the same as f of -3? Okay, so that's how we'll know if it's continuous from the right. Again, keeping in mind that those conditions for continuity are that the limit exists, that f of -3 is defined, and that they're equal to one another. Okay, so again, we'll just do a little tiny bit of work here. So now we have this limit as x approaches, scratch that, we already wrote that. So I want the square root of the limit as x approaches -3 from the right of 9 minus x squared. Is that going to be equal to f of -3? Well, this is going to be the square root of 9 minus -3 squared. The square root of -3, or f of -3, is 9 minus this -3 squared. And you can see we're going to get the square root of 9 minus 9. The same thing we're going to get over here. 0 equals 0. Yes. Okay. Lastly, we need to do the same thing. We need to know if the limit as x approaches 3 from the left of f of x is equal to f of 3. Okay, again, is it continuous from the left? So now that's what we're going to figure out, is the limit as x approaches 3 from the left, square root of 9 minus x squared, equal to f of 3. This is then the square root of the limit as x approaches 3 from the left of 9 minus x squared. Is that equal to f of 3? This is now the square root of 9 minus 3 squared. Is that equal to the square root of 9 minus 3 squared? I hope that we can see that it is. 0 equals 0, yes. Okay. Oh, gosh, we're right at the bottom there. Okay, so where does this take us? F of x equals the square root of 9 minus x squared is continuous on the closed interval -3 to 3. Okay. So again, we had to check all the conditions for continuity on an interval, being that it's continuous on the open interval, it's continuous from the right, and it's continuous from the left. And that's how we do that. Okay, so this is going to be your assignment. I can't believe I got this all done in 2 videos, and I need to hurry because it's about to cut me off, I feel like. So, I'm not sure what pages this is on. It's section 1.5. I'll put it in the Canvas assignment, okay, for you when I get that done. It's going to be 1 through 6 all, and 12 through 22 all, okay? So that's what you should do for the assignment for this section. Starting out on 1 through 4, you're going to be looking at some graphs, trying to determine where functions have continuity and where they don't. When you get over to 12, it wants to know where you might have discontinuity. So again, you want to be thinking about the domain of those functions and then trying to determine if that would impact the continuity of the function at that value. Okay? All right, this is going to cut me off in about 15 seconds. So I'm signing off, and I'll be back next class period with more videos. Yay!